So questions related to projectile. In this question, in a 15th century, an explanation of a projectile went as follows. Like in a 15th century, the physicists explained the projectile. So what they mention, when you throw an object, you give it a force called impetus. It move in a straight line until the impetus is used up. Then the object fall vertically to the ground. So this is what was the 15th century explanation of the projectile. Correct the diagram to show the path followed by the projectile according to modern observation, and assume it has the same initial direction. So if initial direction is same, we will just have to construct the path. So the two-dimension motion will be there. So this will be the projectile motion. Explain why a projectile follow a path you have drawn. Your answer should include reference to horizontal, like why we draw this path. So basically what we have to do, we have to explain why we draw this path. So what is the reason why we draw this path? Because for a projectile motion, what is our assumption? We assume there is no air resistance. So horizontal and vertical components are independent of each other. So the things which you will mention no air resistance. So horizontal component does not change or remain constant. The vertical component accelerate, decelerate and accelerate. So vertical component acceleration and deceleration due to gravity. And horizontal and vertical component are independent of each other. Means what is a horizontal component that will not affect what will be the vertical component. So horizontal and vertical components are independent of each other. So these are the points which will score the marks. In the question they mentioned, when a toy balloon is hit quickly up at an angle, it appeared to follow a similar path. Like example, this you may have experienced. Like example, if a balloon, inflated balloon is there and you hit the balloon, so what trajectory it follow? It rises and then it come down vertically. This is a trajectory followed by the balloon. So this is a path which is similar to that in a 15th century. Explain why the balloon followed this path. So basically, balloon is a practical case. So for balloon, there is a air resistance acting. So when air resistance is acting, so horizontal component does not remain constant. It decreases and eventually it becomes zero. So when the horizontal, so basically the assumption, our assumption, there is no air resistance, so horizontal component is remain constant. But in practical, because there is a air resistance, so horizontal component will decrease, and eventually there is no horizontal component, only vertical component is there. So if only vertical component is there, it will move downward or it will have same acceleration, which is due to gravity. So air resistance acting on the balloon, the horizontal component does not remain constant. It decreases and eventually it becomes zero. And at maximum height, only vertical component so it accelerate downward and there is no horizontal component. Is it clear this question why a toy balloon when you hit it move in the path which we draw or explain in the 15th century? Is it clear this concept of the projectile? So practical, this is what is practically happen when a projectile is launched. Air resistance is opposing a motion, so eventually the horizontal component will be zero and it will have only vertical component, so move downward. But what we assume, this the assumption is that there is no air resistance, so it will have horizontal component constant throughout the motion. So in a question, the first part is actually related to energy. That's why I skipped. But you can also solve the mass is there. The height is in centimeter. You can convert into meter. So it will have a potential energy. So you can use potential energy is equals to mg h. Then energy conversion calculation predict that the projectile speed 16 meter per second. The projectile is observed to fly out in a sling at an angle of 40 to the horizontal. Resolve the velocity to horizontal and vertical components. So basically what they mean, like if a projectile is launched by a sling, so this projectile will come out with a velocity of 16 meter per second, and that is making angle 40 degrees with a horizontal. The question is, what is the horizontal component? So how to get the horizontal component? So the component which is with an angle is written with cos theta and against the angle is sine theta. So the horizontal component will be 16 cos 40 and the vertical component will be 16 sine 40. So 16 cos 40, the horizontal component, what's the answer for 16 cos 40? What is the value for 16 cos 40? 12.3. And what's the value for 16 sine 40? 10.3. So we have the horizontal and vertical components. The predicted range is 27 meter. Means what they mean, like if you launch a projectile with an angle of 40 degrees at a speed of 16 meter per second. So the maximum range, the predicted range is 27 meter. That the projectile can travel 27 meter. But in practical, when measured, the range was found only 8. Means when practically it is launched with the same speed, it only cover 8 meter. What is the reason? Air resistance and friction of the machine are the possible reason. Like definitely if air resistance is acting, the horizontal component decreases, so range will also decrease. Without further calculation, explain another reason why a projectile does not go as far as predicted. Like why it does not travel to the same 27 meter, why it is traveling less. So what could be a reason? Because as you see the previous part, it is related to the previous part. We are using a photograph is there, which is also a war wolf used in a 13th century. Uh, it was used to attack the castle by firing a missile from a sling. So basically what happened, maybe a sling, not all of the energy, this is a projectile, so when it will shoot, so the projectile is launched. But what happened, not all of the energy is transferred to the sling. So if not all of the transferred from the sling to the projectile, so its speed will be different. If speed is different, the range will also be different. So the answer for this part, why the range which we calculated may not be equal to 27 meters, it is less than 27 meter. So the reason is that not all of the energy the project transfer to the projectile, or starting energy will be less. So if not all of the energy transferred to projectile, it will come out with a smaller speed, which will reduce the range. Is it clear? Another question. When a soft mint sweets are dropped into a bottle, which are containing a fizzy drink, there is a sudden release of the gas which forces a long stream of a fluid out from the bottle. Like example, if you have a soft drink or a fizzy drink, like Sprite, Coke, you add soft mint to this, so the liquid, the stream, the gases will come out. So student decided to calculate the amount of kinetic energy transferred to the fluid in this process. In one experiment, student placed the bottle at an angle of 50. So what student did, like he placed a bottle which is filled with a fizzy drink at an angle of 50 degrees. So there's a fizzy drink and he added the soft mint to this. So the liquid will come out. So he found that student then calculated that the fluid left the bottle at a speed of 7.5 meter per second. Show that the initial horizontal component of a fluid velocity is 5. So how to show? We know the speed, the launching speed is 7.5, and we know the angle with horizontal, it is coming out at an angle of 50. So if we need a horizontal component, initial horizontal, so it will be 7.5 cos 50. And show that the initial vertical component is 6. So for vertical component, how we can find the vertical component? So it will be 7.5 sine 50. So horizontal component will be there and the vertical component is also there. In the next part, use your values to calculate the maximum horizontal distance traveled by the fluid. Assume that the fluid leaves the bottle at a ground level. So what we need a maximum horizontal distance. So we know the launching angle was 50 and the launching speed was 7.5 and it moved. So we need a range. Now to calculate a range, the distance And I told you, if you are calculating a horizontal distance, because horizontal distance, there is no acceleration, horizontal component, there is no acceleration. So we can use the formula speed is distance over time. So we have the speed, but what speed? Speed, not the total speed, the horizontal speed. So what was the horizontal speed? It was 7.5 cos 50. So 7.5 cos 50 will be the horizontal speed, because we are finding a range. The distance is a range. So 7.5 cos 50. Distance, we don't know, but there's also unknown. Another unknown is time. So it means I cannot use this equation until I know the time. So first, to get the time, I will use a vertical component and I will find how much time it will take to reach the maximum height. Because if I know the time taken by the projectile to reach the maximum height, then the total time will be twice. So if I want to find the time it will take to reach the maximum height, so at maximum height, I can use a vertical component. How I can use a vertical component? I have this equation, V acceleration is V minus U over T. Or if I need time, time is change in velocity divided by acceleration. So what is the change in the velocity? The vertical velocity is 0 at maximum height. And what is the vertical velocity in the beginning? That was 7.5 sine 50. So I know the initial vertical velocity and I know the final vertical velocity, because at maximum height, the vertical velocity will be 0. So we have the formula, the final is 0. The initial is 7.5 sine 50. Why I'm taking a vertical? Because I'm finding the time to reach the maximum height. And then the total time, because this is a total time. So this total time will be twice of the time to reach the maximum height. So 0 minus 7.5 sine 50 divided by acceleration, which is 9.8, because it is accelerating. Or but if it is, when it is going up, it is decelerating, so negative. So it will be minus 7.5 sine 50 divided by minus 9.8. When what's the answer? 7.5 sine 50 divided by 9.8. What's the time to reach the maximum height? 7.5 sine 50 divided by 9.8. 0.59. So it took 0.59 second to reach the maximum height. So if it took 0.59 second to reach the maximum height, same it will take to reach the ground. So what will be the total time? So this total time will be 0.59 multiplied by 2. And I need a distance. So it will be 7.5. 7.5 cos 50 multiplied by 0.59 into 2, because it will be twice the total time. So what is the distance traveled by the fluid? 0.59 multiplied by 2 multiplied by 7.5 cos 50. So what is the maximum distance traveled by this projectile? 5.69 meters. So 5.69 meter is the maximum distance which is traveled by this projectile. And you can see a 4-mark question. So how we did this? We need a range, the horizontal distance, which is speed multiplied by time. We know the speed, but we don't know the time, total time. So first we got the time to reach the maximum height. and then twice it, so we'll know what will be the time, total time. Is it clear? Discussion? In the next question, the photograph shows a sequence of the picture of a man jumping from 30-meter. Pictures of a man jumping 30-meter from a cliff into a water below. Ignore the first picture and consider the second picture representing the instant he jumped. So ignore this picture. This is a picture when he started the jump. And ignore the final picture, the splashing taking in the 10th. Taking the 10th picture as shown, the time which has fallen. So neglect the last picture, the splashing. So this is what you will consider. Now, what is the question? The diagram shows a 10th picture of a man. It is useful to mark the center of the gravity for each picture and before taking the measurement to analyze the motion. State what is meant by center of gravity and mark approximate position on the diagram. So what is meant by the center of the gravity? It's a point where the weight of an object acts, and you can mark the center of the gravity for the person. Then the vertical distance between the consecutive picture increases, but the horizontal distance remains same. Explain this observation. So what they mean? The horizontal distance remains same. The horizontal. So why the horizontal distance, like between second and third picture, third and fourth pitch, between second and third, third and fourth. So all the horizontal distance appear to be same. But vertical distance, in the beginning, the vertical distance is small, but the vertical distance is increasing between the pictures. So what is the reason why because vertical there is acceleration, and that acceleration is due to gravity. The horizontal there is no acceleration, or acceleration is zero horizontally, so that's why it remains same. So when you write the answer for this, so you will mention that the jumper is accelerating or velocity is increasing for the vertical motion, but horizontally the velocity, it's also a projectile motion. So basically you have to explain why the vertical velocity is changing and the horizontal is not changing. So vertical component is acceleration, which is due to gravity, whereas horizontal component no acceleration. That's why it remains same. Now in the next part, by considering the vertical motion of the picture 2 to 10, show that the pictures are taken at a rate about 3 pictures per second. So how we can show the vertical height fallen is 30 meter. So if the vertical height fallen is 30 meter, so basically we need a time. So how to get the time? So when an object is dropped from certain height, what is the vertical component? Initially the vertical component is 0. And acceleration is due to gravity. And the height from which it fall, that's 30 meter is given. So what we can use this to find the time. We have this equation of motion. I told you equation of motion can be used for vertical motion, as there is acceleration s is equals to ut plus half at square. So s is 30, u is 0, so 0 multiplied by t, the whole factor will be 0. 1 by 2, acceleration is due to gravity, 9.8 t square. So this will be 30 is equals to, this whole factor will be 0. 9.8 divided by 2, 4.9 t square, or 30 divided by 4.9 and take a square root. So you will get t. What's the answer? 30 divided by 4.9 in a square root. 30 divided by 4.9 in a square root. Yeah, what's the answer? 2.5. So what it shows 2.5, because we have to show that the pictures are taking 3 pictures per second. So I'm using this space. So 2.5 second is the total time to fall this 30 meter. And in this 30 meter, how many pictures are captured from 2 to 10? So 8 pictures are there. 2 is there, then 3, 4, 5, 6, 7, 8, 9, 10. So 2 is there, the first picture, and then how many pictures are taken? 8 pictures are taken extra. So it means if 8 pictures took 2.5, because that's the time it will take to fall. So we need per second. So one picture in 1 second, x will be there. Cross multiply, so it will be 8 divided by 2.5. So what's the answer for 8 divided by 2.5? That will be about 3, approximately 3. So when they say about, it means your answer should be similar to that, like 3.1, I guess, will be the answer. Is it clear? So first, using the equation of the motion, s is equals to ut plus half at square, we got the time. Because it is a falling object, so vertical velocity, when an object is launched from certain height, the vertical velocity is 0. Because, and then it will accelerate, its acceleration will be due to gravity. So, and the vertical height was given 30 meters. So using this, we worked out the time it will take to fall. And after knowing the time, and we know how many pictures, so the total picture divided by time interval, we will get how many pictures are taken per second. The next question, the vertical height between the second and the 10th picture is 30 meter. Take the measurement. So it's about a scale diagram. Show that the horizontal distance between these pictures is 12 meter, between 12 and 15 meters. So you have to use a ruler scale. So they mentioned the vertical height is 30 meter. This is the actual. But according to scale, like on the notebook or on the paper, you don't have drawn 30 meter. You will use a ruler or a scale and measure this height. So when you measure this height example, so this height example, this is just an example. So this was 14 centimeter example. So it means 30 meter is represented by 14 centimeter. So the question is, what is the actual horizontal distance? So how to get the actual horizontal distance? You will measure this. Example, this was coming out 6 centimeter. So if 30 meter is equals to 14 centimeter, according to picture, so 6 centimeter will be x. Cross multiply, you will get the answer. Is it clear? How we worked out the horizontal distance between the second picture and the 10th picture. Is it clear? Discussion related to projectile. So using a scale diagram, actual scales, you should be able to calculate horizontal and vertical distance. Now calculate the horizontal and vertical velocity of a man for the 10th picture. Horizontal velocity does not change throughout the motion, and we already worked out that a man fall 30 meter and his horizontal distance is about between 10 and 15. Example, I took 13 meter and this was 30 meters. And how much time it took? So how much time it took, that we already worked out, that was 2.5 seconds. That's a total time it will take to fall this 30 meters. The question is, we need a horizontal and vertical velocity. Before hitting, there will be a horizontal velocity and there will be a vertical velocity. So how to find a horizontal velocity? Horizontal, there is no acceleration. So if there is no acceleration, we can use a simple formula. So for horizontal, as there is no acceleration, we can use the formula speed is equals to distance over time. So horizontal distance, example 13 meter, and the time was 2.5. So 13 divided by 2.5, we'll get the horizontal velocity. But what about the vertical velocity? For vertical velocity, the starting vertical is 0 and the final vertical we need. So how to get a final vertical? If we know the time and acceleration, so we can use v is equals to u plus at. U is 0, acceleration is due to gravity 9.8, and time is equals to 2.5. So 9.8 into 2.5, what's the answer? 9.8 multiplied by 2.5. So 24.5. So vertical was 24.5 and the horizontal 13 divided by 2.5. What's the answer? 13 divided by 2.5. That's equal to 5.2. So we have both velocities, the horizontal and vertical. In the next question, it's about the MCQ, multiple choice. This is a distance, displacement time graph. So what is the right answer? Displacement time graph. For vertical is on the left hand side and horizontal is on the right hand side. For an object until it's land, like an object is thrown horizontally. So this is a half motion, not a full projectile. If object is thrown horizontally from the roof, it will follow a trajectory like this. But this is a half motion, not the full projectile motion. So initial velocity vertical will be 0. Vertical, there is no velocity. Horizontal will be there, and horizontal velocity remain constant. So horizontal velocity will not change. So horizontally, the slope should be constant. So which one is representing a constant slope? So for A or for C, there's a constant slope. But for vertical, what happened? Speed is continuously increasing because the vertical component acceleration is there. So which represent acceleration or speed is increasing. So this is representing speed is increasing. So C is the right answer. Is it clear? Okay, so these are the questions related to projectile. There are many questions. This is a very important topic. You can see there are a lot of questions. This assignment is a lengthy assignment. So we'll continue this discussion of projectile next class. And I will share the weekly homework. When I share the weekly homework, you have to submit the weekly homework every Tuesday for discussion. Before the class, submit your weekly homework so we can discuss. So I'll end the session and share the recording.